under the expansive sky above a massive crimson star, one of the most brilliant and easily noticeable among celestial objects, rules over the horizon. It exists far beyond our full understanding, a vast cosmic body, capable of unleashing energy so tremendous that it could rival the combined brilliance of countless stars. This enormous astronomical entity, possibly on the verge of a cataclysmic event, could soon erupt with a force so great that its radiance may outshine the collective brilliance of a billion suns. The key question remains: is humanity ready for the aftermath of such an event? This enormous red star, commonly referred to as Goliath, lies relatively close to Earth and has become a focal point of intense interest and debate, both among scientists and the public. Recently, the star underwent a dramatic change that has raised alarms and ignited heated discussions about its future. The most alarming possibility is that this change could be an early sign of a supernova, an explosive event marking the final stage of a star's life cycle. If Alpha Orionis, its scientific name, were to run out of nuclear fuel, it could collapse under its own gravity, causing a catastrophic explosion. Just the idea of such an event creates concern not only among scientists but also for those of us on Earth, as the potential fallout could be extraordinary. Alpha Orionis, easily identified by its deep red hue, is the largest and most luminous star in the Orion constellation. Using sophisticated tools like NASA's Hubble Space Telescope, astronomers have been closely observing its behavior, especially in 2019 when it experienced a significant mass loss, a rare occurrence for stars of its type, causing concern within the scientific community. While our Sun regularly experiences coronal mass ejections, the unusual events witnessed in Alpha Orionis have led scientists to reassess what happens in the final stages of a massive star's life. There is disagreement among scientists regarding the exact distance of Alpha Orionis from Earth, with some placing it as far as 1,200 light-years away, while others suggest it is as close as 724 light-years. The difficulty in determining its precise location arises from the immense distances involved and the unique nature of red giants. Despite the uncertainties surrounding its exact position, Alpha Orionis continues to captivate astronomers, remaining one of the most awe-inspiring objects in the night sky, shining multiple times brighter than our Sun. However, this intense radiance comes at a significant cost, as Alpha Orionis is rapidly consuming its nuclear fuel, hastening its journey toward the inevitable end of its life cycle. Once it exhausts its fuel, the star will likely collapse, possibly forming either a neutron star or, in a more disastrous scenario, a black hole, depending on the nature of the explosion. This leads to an important question. Could Alpha Orionis present a threat to Earth? If a supernova were to occur within just a few light-years of our planet, the results would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies. Even if Alpha Orionis is located at a considerable distance from Earth, the consequences could still be far-reaching. The last supernova recorded in our galaxy happened in 1604, and since then, humanity has not experienced a similar event on a local scale. However, a notable supernova explosion occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While this explosion had significant effects on its immediate surroundings, it posed no direct threat to Earth. These rare events, however, serve as powerful reminders of the immense scale of supernova explosions and the potential dangers they bring. A supernova, especially one occurring near Earth, could create a danger zone around the stellar explosion. The risks to life on Earth should be considered in the broader context of cosmic events. While supernovae are relatively rare, gamma-ray bursts, GRBs, represent an even greater threat. These bursts can annihilate entire planetary biospheres by bombarding them with deadly radiation. For instance, GRBs could destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its star. Effects like these could persist long after the burst subsides. This looming danger of GRBs has become a primary focus for current research, shedding new light on the potential hazards of stellar explosions that lead to such catastrophic events. When massive stars explode as supernovae, their brightness can outshine entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis underwent a similar transformation? If it were to explode as a supernova, it could become the second brightest object in the sky after the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion could be so intense that it might be visible during the day, offering a breathtaking yet disconcerting spectacle for anyone witnessing it. While the visible light emitted by a supernova would undoubtedly be mesmerizing, the real danger lies in the high-energy radiation accompanying the explosion. This radiation, typically in the form of X-rays and gamma rays, could have far-reaching consequences. One of the main concerns is the potential depletion of Earth's protective ozone layer. Without this shield, life on Earth would be exposed to harmful levels of ultraviolet radiation, which could lead to mass extinction events. The dangers associated with a supernova do not dissipate immediately following the explosion. The remnants, including shock waves that travel nearly at the speed of light, would continue to pose threats as they propagate throughout the solar system. These shock waves could further damage the ozone layer, exposing Earth to even more harmful radiation that would only intensify over time. Additionally, the long-term effects of the energy released by a supernova could last for centuries, leaving lasting damage on the planet. Interestingly, some studies suggest that Earth may have already been impacted by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced during supernova explosions, have been discovered in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the fallout from such an event in its geological past, possibly within the last few million years. Currently, no known supernova candidates pose an immediate threat to Earth. However, ongoing research continues to uncover new potential risks, especially from supernovae capable of emitting long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material, and the shock waves from the explosion interact with this material, generating intense X-ray radiation that can travel vast distances through space. This radiation can affect planets within a 150 light-year radius. Fortunately, no such candidates have been identified near Earth. Nonetheless, this research has provided fresh insights into the concept of the habitable zone, the region of space where conditions may support life. It appears that this zone may be more restricted than previously believed, with the outer regions of galaxies lacking sufficient star formation to support the development of rocky planets. On the other hand, the inner regions, where stars are born and die more rapidly, may pose risks due to the frequent occurrence of supernovae. As scientists continue to explore the remnants of supernovae, they are discovering that these cosmic leftovers can give rise to new stars, forming stellar nurseries from the material ejected during the explosion. This process illustrates the interconnectedness of the universe, where the death of one star often leads to the birth of another. Furthermore, supernovae have proven to be invaluable tools for measuring cosmic distances. Type Ia supernovae in particular are used as standard candles, enabling astronomers to measure distances between galaxies with remarkable precision. This method has refined our understanding of the vastness of the universe and provided vital information about dark energy and the accelerating expansion of the cosmos. The remnants of supernovae, consisting of the material expelled during the explosion, play a crucial role in the formation of new stars. These remnants act as stellar nurseries, where fresh stars emerge from the gas and dust left behind. This cyclical process, where the death of a massive star leads to the birth of new generations of stars, drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to study supernova remnants, they are finding that new stars can emerge from the gas and dust in these regions, even years after the initial explosion. Supernova remnants, with their complex compositions, are also one of the universe's primary sources of heavy elements. Elements such as iron, gold, silver, and uranium are formed in the extreme conditions of a supernova explosion and are scattered into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system and our existence would not be possible. Supernovae, therefore, are not just destructive events. They also play a vital role in the creation of the very elements that make up the stars and planets we observe today. Furthermore, the study of supernovae has deepened our understanding of the universe's expansion. By observing the brightness of type Ia supernovae caused by the explosion of a white dwarf in a binary system, astronomers can measure cosmic distances with extraordinary accuracy. These standard candles have revolutionized our ability to map the universe, providing crucial information about dark energy and the accelerating expansion of space. Despite significant advancements in our ability to measure cosmic distances, the potential dangers posed by supernovae cannot be overlooked. While the likelihood of a nearby supernova affecting Earth remains low, the long-term consequences of such an explosion could be profound. As mentioned earlier, supernovae emit intense radiation that could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life to harmful ultraviolet radiation from the sun. Without the ozone layer, survival on Earth could become increasingly difficult, if not impossible. Additionally, the shock waves from a nearby supernova could disrupt the structure of the solar system. These waves could compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could disturb the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even threatening Earth's existence. The study of supernovae and their remnants also raises intriguing questions about the future of the universe. As stars die and supernovae occur, their remnants can eventually form black holes or neutron stars, two of the most enigmatic and extreme objects in the cosmos. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. These objects are believed to be the final stage for the most massive stars, and their formation is one of the most fascinating phenomena in modern astrophysics. Despite their destructive nature, supernovae are integral to the ongoing evolution of the universe. The materials they release into space serve as the building blocks for the formation of new stars and planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the universe's ever-expanding nature. In conclusion, while the potential threat of a supernova explosion remains a distant concern for Earth, studying these events is essential for advancing our understanding of the universe. Supernovae not only provide valuable insights into the life cycles of stars, but also offer crucial information about the chemical composition of the cosmos and the ways in which galaxies evolve over time. As we continue to explore the vast reaches of space, our understanding of these dramatic cosmic events will deepen, offering a clearer and more comprehensive view of the universe's past, present, and future. As we move forward in our exploration of the universe, it is clear that studying these immense cosmic phenomena will continue to reveal new layers of understanding about the universe and its intricate mechanisms. Each step in this research brings us closer to grasping the true scope of how stars live, die, and contribute to the dynamic, ever-evolving universe around. Supernovae and their aftermaths, such as neutron stars and black holes, represent some of the most fascinating and mysterious aspects of astrophysics. These phenomena raise profound questions about the ultimate fate of stars and their role in the larger cosmic framework. The processes leading to a supernova explosion involve extremely complex nuclear physics, yet the resulting impacts stretch across vast distances, influencing the evolution of entire galaxies, the birth of new stars, and enriching the cosmos with essential heavy elements. Understanding how these events unfold and the conditions that trigger such explosive occurrences helps scientists piece together the puzzle of stellar evolution. In addition to the critical role they play in star formation and the creation of elements, supernovae serve as a critical tool for measuring cosmic distances. By analyzing the light from these dramatic stellar explosions, astronomers can create more accurate maps of our universe, tracing the expansion of space and the distribution of galaxies across vast distances. These measurements are essential in determining the age, scale, and structure of the universe. They have led to groundbreaking discoveries regarding the mysterious force known as dark energy, which appears to be accelerating the expansion of the cosmos. This precise ability to measure distances using supernovae has had ripple effects throughout astrophysics, providing more detailed and reliable methods for gauging distances across the universe. We have gained a deeper understanding of the rate at which the universe is expanding and how galaxies are evolving. The presence of dark energy, first inferred through observations of distant supernovae, has reshaped our understanding of the universe's future, suggesting that the cosmos is not only expanding but doing so at an accelerating rate. Yet, despite the incredible knowledge gained from these studies of supernovae, the potential risks from a nearby supernova explosion remain a fundamental concern. While such an event is unlikely in the immediate future, the possibility, however remote, demands our attention. The destructive effects accompanying supernovae, particularly the radiation and shock waves they generate, could have significant impacts on nearby planets. If Earth were to fall within the range of such an event, the consequences would likely be catastrophic. From the destruction of the ozone layer to the disruption of the solar system's delicate balance, understanding these risks forces scientists to think deeply about how life on Earth could be affected by cosmic events. If humanity can continue to monitor and study supernovae and their aftermaths, it will help us better predict and prepare for potential threats from these cosmic giants. While the threat remains distant, supernovae serve as a powerful reminder of the immensity and unpredictability of the universe.